Hi everyone, today we are going to solve another question on Newton's law. Let's read the question. Two masses m1 equals 10 kg and m2 equals 2 kg are connected by a light string over a massless frictionless pulley. You're asking for the magnitude of acceleration of mass m1 when the system is released. In the other videos that I have talked about Newton's law, I introduced a few steps. If you remember, the first step was to draw the free body diagram for each object. I'm going to do the same thing in here. But before doing that, I'm going to pick a direction for the motion of the system of the two objects. Because M1 is heavier than M2, therefore M1 is going down and M2 is going up. Therefore, I can say that the system is actually moving counterclockwise. So for M1, the positive direction is downward, and for M2, the positive direction is upward. Then I'm going to draw the forces acting on M1. The Earth applies the force of M1G to M1, and the tension force is the force from the rope, the string acting on object M1. Also, the Earth applies M2G to block M2, and the rope, the string, applies the same tension force to object 2. It's the same tension as it acts on M1 because it's the same rope going over the pulley, and the pulley is massless. So step 1 was to draw the free body diagram. Now, the way that I'm going to solve this question is to take both M1 and M2 as one system. And the reason I'm going to do this today is because they only ask for the acceleration of mass m1, which is the same as acceleration of mass m2. They're not asking for the tension force, and because of that, I'm going to combine m1 and m2 into one system. And the next step is to write down Newton's law for the system of the two objects. So I can write F net equals m times A. The net force that's acting on the system is the sum of m1g and m2g. But m1g is a positive force because I took downward as positive for m1. So I can write m1g minus m2g. Why? Because m2g is downward, and for object 2, for mass 2, I took upward to be the positive direction. So Fnet is the sum of the forces acting on the system of the two objects. I should note that I did not include the tension in here because the tension forces are the internal forces, and we do not include the internal forces if we take M1 and M2 as one system. So Fnet equals, this mass now is the total mass. It's M1 plus M2 times the acceleration of the system. If you isolate this equation for the acceleration, we will end up having m1g. You divide both sides by m1 plus m2 minus m2g divided by m1 plus m2. If you look at the bottom of this fraction, you have the two masses added. It doesn't matter what kind of system of the two objects you have. If you don't end up adding the masses at the bottom of the fraction for the acceleration, we've made a mistake. So for any kind of system of two objects, the masses should add up at the bottom of the fraction for acceleration. Now I'm going to sub in the numbers. So I have 10 times 9.8 minus 2 times 9.8. 10 and 2 are the values for masses, divided by m1 plus m2, which is 10 plus a 2. Well, if you do the math using your calculator, you're going to end up getting 6.5 meters per second squared. And meters per second squared is the unit of acceleration. So m1 is going down with the acceleration of 6.5 meters per second squared, and m2 is moving up with the acceleration of 6.5 meters per second squared. So the answer would be part B.